Hi, it's Lawrence again. I've just finished my latest project, a drill sharpener. I hope you like the video. It's about 5.5 minutes long. I've learnt a lot while making this, a few mistakes on the way as ever, but I've enjoyed the project and it's been very successful. So overall I'm very pleased. This is a CAD model of the drill holder. I wanted to incorporate some modern manufacturing techniques into the design, so I decided to manufacture the jaws using a 3D printer. The plastic we used is ABS and the jaws are not solid, there's a honeycomb structure within them, thus reducing the amount of material used and also providing strength and rigidity. This next video footage shows how I machined the two critical dimensions on the drill sharpener. The actual angle of the faces isn't critical. What's important is both faces must be exactly the same angle and set exactly the same distance from the centre line. In order to achieve this, I assembled the jaws onto a 1/2 inch piece of silver steel, which is held in a rotary table. The faces were pre-machined on an earlier setup, so that all I had to do was take about 0.2 or 0.3 of a millimetre off and then rotate the table 180 degrees, and with the same settings on the milling machine take exactly the same cut on the other side. As you can see from this setup, my milling machine was tilted so the head was at 45 degrees approximately to the work, and then it was just a simple matter of facing across and taking the final 0.2 or 0.3 millimeters. I used a small fly cutter with just a standard high-speed steel tool which I'd ground up, and it worked pretty well. Once both faces had cleaned up, I was ready to move on to the drilling. Again, the hole positions are not critical. The important thing here is exactly the same as the faces. They must be 180 degrees apart. The drawing shows that they're offset from the face, centre line of the face, by about 10 millimeters. So I marked out in red marking ink, scribed the lines and centered up on that point. Then it was a simple matter of just drilling, starting with a center drill, small amount of oil, and I think I progressed up with a 4mm and then a 7mm drill before finally reaming at 9:30 seconds. You'll get a far better appreciation for the setup from this next video footage. I used toolmaker's clamps and tall angle plates to ensure the work could be held securely onto the rotary table. My biggest concern was that the silver steel could flex slightly during the fly cutting operation. That's why I made the angle blocks so tall, to try to stiffen the setup and provide good support for that machining operation. I wanted to use a fine grit grinding wheel and managed to drop on a 120 grit wheel from our Curo trade. Looked good. I put it on my cheap grinder. In this video I've taken all the guards off so you get a good appreciation for the setup and how the drill sharpener is used, and you can see the importance of the accuracy of those datum features I talked about earlier. The flats and the holes, they are the critical features, and they've got to be offset from the centre line. You can see you turn it over 180 degrees, grind one facet, and then turn it back over and grind the other facet of the drill. If those dimensions are spot on, then every drill you sharpen will be very accurate. And the drills I've sharpened with it are fabulous. And finally, the finished project. The grinding wheel with guards attached and a new 6mm Lexan shield, the indexing base and pivot post, and the drill holder. I've had a go at 4mm, 5mm and up to 1/2 inch drills so far, with good success. I'm getting a really good surface finish with that 120 grit grinding wheel, and there's a knack to it for sure. You really have got to just learn how much to rotate the drill, and also the amount the drill protrudes from the drill holder. That also affects the clearances. But overall, I'm really pleased. A good project. It works well. If you've got any drills need sharpening, you know where to come. Thanks for watching, guys. Bye.